Imagine receiving one final photograph from the most distant spacecraft ever built. There are no bright planets filling the frame. No colorful nebulae. No dramatic explosions lighting up space. Only darkness stretching in every direction, interrupted by a handful of faint points of light. At first glance, such an image might seem unremarkable. It could easily be dismissed as the quiet ending of a mission that has lasted for decades. But astronomy has taught us an important lesson. The smallest details often tell the biggest stories. Voyager 1 began its journey in 1977, carrying humanity's curiosity far beyond the familiar worlds of our solar system. Engineers designed the spacecraft to explore the giant planets, but few imagined it would continue traveling for nearly half a century, becoming the most distant human-made object ever sent into space. Its first major destination was Jupiter. As Voyager approached, the giant planet transformed from a blurry disk into a world of extraordinary complexity. Massive storms swirled through its atmosphere, lightning flashed within towering clouds, and powerful radiation surrounded the planet like an invisible shield. The spacecraft also revealed remarkable discoveries on Jupiter's moons. Io was found to be covered with active volcanoes, making it the most volcanically active world known. Europa displayed a smooth, icy surface that hinted at the possibility of a hidden ocean beneath its frozen shell. Each new image challenged ideas scientists had held for years. Voyager then continued toward Saturn, where another surprise awaited. From Earth, Saturn's rings appeared elegant but relatively simple. Up close, they proved to be incredibly detailed. Countless icy particles formed thin bands, dark gaps, twisting waves, and delicate structures shaped by gravity. Every photograph revealed patterns that no telescope had ever seen before. These were not artists' impressions or computer-generated scenes. They were real images captured by a spacecraft traveling through places no human being had ever visited. After completing its exploration of the outer planets, Voyager performed one of the most meaningful actions in space exploration. Before continuing toward interstellar space, it turned its camera back toward home. From billions of kilometers away, Earth appeared as a tiny point of light suspended in a beam of sunlight. That image, known around the world as the pale blue dot, became a powerful reminder of how small our planet truly is. Every mountain, every ocean, every civilization, and every person in history existed on that almost invisible speck. Following that historic moment, Voyager's mission entered an entirely new chapter. It was no longer searching for planets. Instead, it became an explorer of the space between the stars. As the years passed, the spacecraft moved farther from the Sun. Sunlight grew weaker. Temperatures dropped. The familiar worlds of the solar system faded behind it. One by one, onboard systems were carefully shut down to conserve the remaining electrical power generated by its aging nuclear source. Eventually, Voyager's cameras were no longer needed for its scientific mission. Their work had ended long before the spacecraft reached the edge of the Sun's influence. Yet people often wonder what its final photographs revealed. Suppose one last image arrived from the darkness. At first, it might appear almost completely empty. But in deep space, appearances can be deceiving. What seems like nothing may simply be something too faint, too distant, or too mysterious to recognize immediately. For astronomers, empty space is rarely truly empty. It contains tiny dust particles, energetic radiation, magnetic fields, and distant stars whose light has traveled for millions or even billions of years before reaching a camera. Sometimes the greatest discoveries begin with a single unexplained detail. A faint glow. A tiny streak. A barely visible point of light. Whether it turns out to be an instrument effect or a genuine celestial object, careful investigation is always required. That is what makes Voyager's journey so remarkable. Even after decades of exploration, it reminds us that the farther we travel into the universe, the more questions we discover waiting in the darkness. As Voyager 1 continued its endless journey, the familiar planets disappeared behind it. Ahead lay a region unlike anything the spacecraft had explored before, a place where the sun's influence gradually weakened and interstellar space began. Crossing this invisible boundary was one of the greatest milestones in the history of space exploration. Voyager was no longer studying planets or moons. Instead, it became a scientific observer of the environment between the stars, measuring energetic particles, magnetic fields, and cosmic radiation that had never been sampled directly by a human-made spacecraft. Yet this new frontier presented an unusual challenge. The farther Voyager traveled, the less visual information it could provide. The cameras had already completed their mission years earlier, leaving the spacecraft to communicate mainly through scientific instruments and a radio signal so faint that it takes powerful antennas on Earth to detect it. Even today, every message from Voyager requires extraordinary patience. Traveling at the speed of light, a radio signal takes more than 20 hours to cross the enormous distance between the spacecraft and Earth. A simple command sent from mission controllers cannot receive a response until nearly 2 days later. This delay reminds us just how isolated Voyager has become. It is moving through a region where sunlight is dim, temperatures approach absolute zero, and the nearest stars remain unimaginably far away. When scientists receive data from such an extreme distance, every measurement is carefully examined. A sudden spike in radiation, an unexpected change in magnetic fields, or an unusual reading from a detector does not automatically signal a new discovery. Engineers first investigate whether the anomaly could be caused by aging electronics, cosmic rays, or natural variations in the surrounding environment. History has shown that many mysterious signals eventually find ordinary explanations. High-energy particles can strike electronic components and briefly alter a reading. Tiny fluctuations in temperature can affect sensitive instruments. Even the spacecraft's advanced systems slowly change after decades in the harsh conditions of space. But not every question is answered immediately. Occasionally, Voyager records observations that require years of analysis before scientists fully understand them. These unresolved puzzles are an important part of scientific research. Rather than jumping to extraordinary conclusions, researchers compare measurements, test competing ideas, and gather additional evidence whenever possible. This careful process is one of science's greatest strengths. Curiosity begins the investigation, but evidence determines the conclusion. Voyager itself has become an extraordinary engineering achievement. Designed for a mission expected to last only a few years, it has remained operational for decades beyond its original plan. Engineers continue to manage its remaining power by shutting down non-essential systems one at a time, extending the mission for as long as possible. Someday, the spacecraft will fall silent. Its power source will no longer produce enough electricity to operate its instruments or transmit data back to Earth. When that day arrives, Voyager will continue traveling through the Milky Way without anyone listening. Even in silence, its journey will continue for millions of years. Long after Earth has changed beyond recognition, Voyager will still be drifting among the stars, carrying the famous Golden Record, a collection of sounds, music, greetings, and images created to represent life on our planet. Whether another civilization ever discovers it is impossible to know. The chances are incredibly small. Yet the record was never only about being found. It was also a message about humanity itself, our curiosity, our creativity, and our desire to reach beyond the limits of our own world. Perhaps Voyager's greatest achievement is not the photographs it captured or the distance it traveled. It is the perspective it gave us. By venturing farther than any spacecraft before it, Voyager revealed that exploration does not end where maps become empty. It begins there. Every kilometer it travels reminds us that the universe is larger than our imagination and richer than our expectations. The unknown is not something to fear, it is an invitation to keep asking questions. And somewhere in the endless darkness between the stars, Voyager 1 continues its silent voyage, carrying with it one small piece of humanity, moving steadily into a future that no one on Earth will ever fully witness.